Hi everyone, this is a revision sheet for Leaving Cert Higher Level Maths Differentiation. So just on the topic of differentiation. So it's a very big topic. It comes up on paper one. It almost definitely will come up in section A and in section B of paper one. So there's an awful lot of marks going for this topic, and it's a very big topic. It's two chapters in most of the textbooks. So I'm going to try and put it all onto one sheet or summarize the basic parts of it at least. So what you need in order to be able to get some good marks in the question. All right. So this doesn't include everything. So I've left some stuff out, but it's most of the stuff that will be in uh, differentiation. So that's the top half of it, and that's the bottom half of it. So I'll just start going through it here. So the very first thing in the top corner there is first principles. So when you're differentiating by first principles, it's about this thing that's in the green here. So the first thing you have to do is the f of x plus h, then subtract f of x, then put it over h, and then do the limit as h tends to 0. So in my example here, I have f of x is equal to x squared minus 6x. So if I do f of x plus h, I just put an x plus h in instead of the x. Now here I have to, and this will generally always happen, you have to multiply out the x plus h squared. So you have to do x plus h. So that's where you're getting x squared plus 2hx plus h squared. And then minus 6, it just multiplies in. The next step then is to subtract f of x. And when that happens, generally things will always cancel out. So you've got an x squared, the x squared is cancelled out here, and the 6x and minus 6x cancel out. Next thing is to divide by h, and then at the end you have to do limit as h tends to 0. If you don't know much about limits, really all it means here is that you turn whatever h's are left into zeros. So you end up getting 2x minus 6. Very important as well to put all of that on the left hand side, so don't leave out any of that I'm highlighting there, because they'll take marks off you in the exam. Next thing is just basic differentiation. So what you do is you do the power multiplied by the number in front and then reduce down the power. So in this one, when I'm differentiating x cubed, really that's a 1x cubed. So 3 times 1 is 3. That's where we get the 3 down here. And then it's x and then to the power of 2, because 1 less than 3 is 2. When you're differentiating 3x squared, 2 times 3 is 6, and then it's x to the power of 1, or just x, and then minus 5x. Really there's a 1, the x to the power of 1, so 1 multiplied by minus 5 is minus 5, and then it's x to the power of 0, which is just 1. So if you have something like that at minus 5x, it just differentiates to 5. Then the minus 17 is a constant, so that will differentiate to nothing. It's just gone. So it's the same as, the reason is because it's minus 17x to the power of 0 really, and then 0 times minus 17 is 0, and then so the whole thing is gone. So if you have a constant, it disappears. You just have to remember that. Remember, f dash x and dy dx are the same thing, okay? So whenever you see these things, they always mean the same thing, and they mean the slope of the tangent. So if you take any slope anywhere, if I want to know what is the slope of the tangent at that point, okay, um, that's what differentiation is. Okay, we differentiate and then we sub in whatever x value we want. So if you had another curve here, if I wanted to know the slope of the tangent here, uh, I just differentiate the function, whatever the function is, and you sub in whatever x value it is then, and it tells you the slope of the tangent. That's really what differentiation is about. I won't get into it too much here because it's a summary video. Next thing is chain rule. So in this is when you have a function within a function. That's one way of thinking about it. It's quite tricky actually. Differentiate as normal, then multiply by the differential of what is inside. So here we have something being cubed, okay, but we have the 2x squared minus 1 kind of inside. So if that question was just y equals x cubed, you just do 3x and square, okay? But it's not just that, it's got this inside. So that's what we do first. We do 3 times what it is, the 2x squared minus 1 squared, okay, because we're just reducing down the power from a 3 to a 2. But then we have to multiply by the differential of what is inside. So the differential of 2x squared minus 1 is 4x, okay, because 2 times 2 is 4x, okay, and the minus 1 disappears because it's a constant. The same thing applies down here. It's just that we need to know that square root is the same thing as power of a half. So again, we're doing a half times 3x squared minus 2, and then we do 1 less than a half. So a half take away 1 is actually minus a half. So that's why the power is minus a half. And again, we multiply by the differential of what is in here, or that thing differentiated, so that is 6x. And we have to multiply by 6x then. And I should probably multiply the 6x by the half there out in front and simplify it a little bit, but I didn't. Next thing is product rule. Product rule is when we've got two things with x in them and they're being multiplied by each other. So here we've a 6x squared plus 2x and a 3x minus 2. And we call one of them u, the other one v. The product rule itself is in the log tables. It's u dv dx plus v du dx. So I let u be 6x squared plus 2x here, and I find the u dx. I just differentiate, and then I let v be 3x minus 2, and I differentiate it. dv dx is 3, and then it's just subbing the things in. So u is 6x squared plus 2x, dv dx is 3, we put in plus, v is 3x minus 2, and du dx is 12x plus 2. Quotient rule is very similar idea, it's just that now it's two things that are being divided. So here I have an x squared plus 7 over a 3x minus 1. I let the top one be u, the bottom one be v. I do the same thing again. There should be a 1 there. So I find I find du dx, I find dv dx, I sub them into this, so I have to put in v, then du dx, then minus u dv dx, put it all over v squared, and that's it. So that's what I've done there. So quotient rule is used when you've got two things being divided and there's an x in them or a variable in them. Right, so differentiating we're missing one. So trig functions first. Trig functions, sin differentiates to cos differentiates to minus sin, and tan differentiates to sec squared. You don't see tan as much as the other ones. So we have to use chain rule when you differentiate a trig function. So if I'm differentiating y equals cos 2x, that just differentiates to minus sin 2x, because as we said, cos goes to minus sin, and all of those are in the log tables up there, so you just have to go straight to your log tables when you're going to differentiate a trig function. So cos 2x differentiates to minus sin 2x, but we have to multiply by the differential of what is inside, like we did in the chain rule before. So the differential of 2x is 2. Same down here, I'm differentiating sin of 5x squared plus 3x, so that differentiates to cos 5x squared plus 3x. But we multiply by the differential of what is in here, which is 10x plus 3. So that's trig functions. Differentiating e, so e to the x differentiates to e to the x. So it differentiates to the same thing, but again, chain rule applies here. So y equals 5e to the x, that just differentiates to 5e to the x. There's a number in front, which doesn't really impact. But the bottom one here, we have 3e to the 2x squared minus 5x. So that just differentiates to 3e to the 2x squared minus 5x. But whatever is up in the power, and that's the important thing here, whatever is in the power, we have to multiply by the differential of that. So we're multiplying by the differential of 2x squared minus 5x here, which is 4x minus 5. Maximum and minimum points. When you get a question on maximum and minimum points, you're going to differentiate and then let it be equal to 0. So here it's find the turning point, okay? So this is a quadratic, so it looks something like that on the graph. At a turning point, at a minimum point, or if it was a maximum point, if it was like that and was up there, the tangent is always going to be a flat line. So that's the only way you can draw a tangent at a minimum point or a maximum point. It has to be a flat line. So because it's a flat line, the slope of that flat line has to be 0. So every maximum or minimum point, it doesn't matter what graph it's on. So if it was a cubic as well, okay, that minimum point there, tangent is a straight line, the maximum is a straight line, so they're both their slopes are 0. So that's why we let it be equal to 0. So if you just remember that maximum and minimum, when you see that in a question or something about that, you're always going to differentiate and let equal to 0 and then solve, okay? And that's really most of what you have to remember with this. So here, the differential of that quadratic is 2x plus 6. So I do 2x plus 6 is equal to 0 then, and I solve for x. So x is minus 3. And when we get that, we just have to sub that back into the original. So it's always the original function you sub it into. And that gives you your y value then, and that gives you the turning point. So that is the minimum point of that quadratic. So max or min, differentiate, let it be equal to 0, work out what x is, sub x back in, and it gives you your y coordinate then. Point of inflection, we're going to differentiate twice. That's what d2y dx squared means. And then you let it equal to 0. So what a point of inflection is, usually it's on cubics that they'll ask you. It's this point here. It's kind of the point in the middle. So it's when the curve stops curving down and starts kind of curving to back up again. So it's when it goes from concave down to concave up is the technical definition. So here I just have to differentiate. So I do that, and then I differentiate it again, and I get 6x minus 18. And then I let that be equal to 0, and I solve for x. X is 3. And again, it's the original one I sub back into. So it's this one that I sub back into. So that gives me the point in the end, 345. So that is the point of inflection on that curve. So that's all that I'm going to go through here. This doesn't have everything from the topic of differentiation. It has the basic parts of it. There are parts I left out, for example, rates of change, and there's some other bits that are in your book uh, that you may need to go through as well. But to be honest, I think if you nail all of this stuff, I think you'll be able to attempt most questions on differentiation, and you should be able to get a good few marks from each question. So that's it. Thanks for watching the video.